Effective representation of playtesting data is one of the current challenges in the game development industry. Researchers are developing a set of techniques and tools to measure and study players' behavior to provide information for game developers in order to optimize the player experience of their games. One major challenge is the sheer quantity of data that needs to be analyzed and understood. This can often be daunting and confusing to decipher. This requires game developers to painstakingly review often large-scale playtesting data to make improvements to their games. To address this, we have been developing a tool to assist the collection and representation of playtesting data, such as players' in-game behavior, such as tracking their movements, and physiological measures, such as tracking their arousal state. Although various data representation or reporting techniques have already been introduced, most of these techniques only focus on statically displaying large amounts of data captured directly via telemetry without integrating qualitative or contextual data on players' emotional experience. The tool we have been developing is a Unity 3D-based plugin that facilitates the gathering of playtesting data, visualizes this data, and provides an interactive, in-game 3D environment for players to explore and interact with. The visualization can be viewed from different angles, for instance, free fly, player's eye, and bird's eye view. The tool represents the data as an extra metadata layer over existing level design. Following from previous research, we currently collect movement data, which is obtained at regular time intervals using telemetry methods. Physiological data is captured in the form of galvanic skin response to measure the player's arousal state. The movement data is represented by rendered lines showing the path of the players and has a specific color based on the recorded galvanic skin response value. These colors range between green, which is a low level of arousal, and red, which is a higher level of arousal, to provide a clear visual interpretation of the player's emotional state throughout their playthrough. Being able to interact with the data in a 3D environment is the key feature of the tool, where game developers can explore and interact with the visualization either using their computer screen for 2D view or an Oculus Rift or Cave for 3D viewing. In this interactivity demo, we will present our tool and different data visualizations on various game prototypes. Conference attendees will be able to explore and interact with our visualizations in both 2D and stereoscopic 3D on the Oculus Rift. The tool is designed as a Unity plugin, so the conference attendees can also bring their own Unity games to try with our tool. Our tool is aimed at game researchers and indie game developers who need an accessible and effective tool for collecting and representing playtest data.